Today I'm going to talk about solving triangles. I would like to start with this warm-up. I would like you to use trig in order to solve these. Solving means finding all the missing sides and all of the missing angles. Press pause on your video, and when you're ready for the answer again, press play. All right, so you can see here that in my first triangle, I knew this angle, 22, and I wanted to find y. So 22 degrees is opposite 14, so sine of 22 is the opposite over the hypotenuse, or opposite over y. I multiplied both sides by y and divided both sides by sine of 22 and got 37.4. So that is the length of my hypotenuse. To find this side, I used tangent. Now, I could have used Pythagorean theorem because I have two sides of a right triangle, but since this is rounded, I did not want to carry forward any kind of rounding error because sometimes it can be significant. So instead, I used tangent in order to find side x. Tangent of 22 is opposite over adjacent, or 14 over x. I multiplied both sides by x and divided both sides by tangent of 22. And I found that side was 34.7. Now looking at this second triangle, this time I have two sides and I want to find the two angles and the third side. So first you should be able to realize that this is a right triangle with two sides. You should be able to find the third side by using Pythagorean theorem. And it happened to be a triple, and that side's 12. Now I have to figure out how to find the angles. Well, if I'm looking for angle y, 5 is adjacent to it and 13 is the hypotenuse. So I used cosine of y here equals 5 adjacent over 13 hypotenuse. To find the angle, I used inverse cosine of 5 over 13, making sure my calculator was in degree mode because I wanted a degree out. And then once I had that, I could find the second angle by taking 90 and subtracting 67.4, because the acute angles in a right triangle sum to 90 degrees. Now, today we are going to continue solving triangles. I'm going to discuss the law of sines today. Next lesson, I'm going to discuss law of cosines. These two laws allow us to solve triangles that are not right triangles. So the first thing we need to know is how to label a triangle, because a lot of times you're given measurements without the triangle drawn. And I have a triangle here named ABC. I want you to notice opposite my vertex A is lowercase a. That stands for my side length. Opposite vertex C is lowercase c. Opposite vertex B is lowercase b. These are my side lengths. Sometimes in books we just say this is angle A, but sometimes they call it alpha. Sometimes we just say angle B, but sometimes they call it beta. And angle C is sometimes called gamma. So you just need to know that in order to draw your triangles appropriately. So where does the law of sines come from, and what is it? Well, what we're doing here is we're trying to find a relationship between angles and sides of non-right triangles so that I can find other pieces. So I've drawn this triangle in, and I've drawn an altitude to the third side, and I've called it the height. I really don't want the h in my formula because I don't want to find the height every single time. So let's label our sides. This would be side A, this would be side C, and this would be side B, but we're not going to quite use that. So looking at angle A, I know that the sine of A is going to be the opposite over the hypotenuse. My opposite is H, my hypotenuse is C. And now looking at angle C, sine of C equals my height, H, opposite, over A. Well, I don't want my H to be in my formula, so I'm going to solve each of these for H. And this one would be A sine of C. Now, I know since both of these are equal to H, that they must be equal to each other. C sine of A equals A sine of C. So, dividing both sides by A and dividing both sides by C, I can see that sine of A over lowercase a equals sine of C over lowercase c. Now, if I continue and I split my triangle around and draw a different height, I will also find that this is equal to sine of B over lowercase b. This is the law of sines. And it essentially says that the ratio between the sine of my angle and the side opposite it is consistent throughout a triangle. So let's take a look at an example. I'm going to draw myself a generic triangle and name it ABC. Alpha is 32 degrees, beta is 40 degrees, and side B is 6.2. In order to use the law of sines, you must have an angle and the side opposite it given or have a way to find it. So I can use the law of sines here in order to solve the triangle. I'm going to name this side A and this side C. The first thing I'm going to do is find angle C. And I can do that by subtracting 180 from, I can subtract 32 and 40 from 180. So 180 minus 32 minus 40 is, 180 minus 32 minus 40 equals 108. So now that I have that, we'll use the law of sines. Sine of 40, that's angle B, over 6.2, that's side B, is equal to sine of 108 over C. Now, I'd like to solve for C, so I'm going to cross multiply. C sine of 40 equals 6.2 sine of 108. And now we'll divide both sides by sine of 40. Now, plugging all that into my calculator, I have 6.2 sine of 108 divided by sine of 40 here. So now I know that's approximately 9.2. And now I have side C. I'd also like to find side A. So we're going to start over. Sine of 40 over 6.2 equals sine of 32 over A. Same kind of idea. We cross multiply. And divide both sides by sine of 40. And then plug into the calculator. 6.2 sine of 32 divided by sine of 40. And that is about 5.1. Now I want you to look at this triangle carefully. Every single time we're done solving a triangle, we need to check to make sure that it makes sense. It's going to make sense if the smallest angle is across from the smallest side and the largest angle is across from the largest side. So my largest side here is 9.2 and 108 is my largest angle. My smallest side is 5.1, 32 is my smallest angle. So this is the solution to my problem. Now, I want you to give this one a try. Notice I'm not asking you to solve the triangle. I'm asking you just to find side length C. Press pause on your video, and when you're ready for the answer, press play again. So you can see that I've drawn my generic triangle, and I was looking for side C, so I did sine of 50 over the opposite side 13 equals sine of 20 over its opposite side C. I cross multiplied. I divided both sides by sine of 50. I plugged into my calculator. I got 5.8. Here's another problem that I'd like you to give a try. Press pause on your video. When you're ready for the answer, press play again. Here's my answer. So I have a pole tilting towards the sun at an 8-degree angle from the vertical. So you can see that I've labeled that 8 degrees. And it casts a 22-foot shadow. So here's my shadow, 22 feet. The angle of elevation from the tip of the shadow to the top of the pole, that's here, is 43 degrees. I want to know how tall this pole is, even though it's not standing straight up and down. Well, I have this angle 43, and it's opposite the length that I'd like to know. Now I need to have the angle opposite the side I know, so I had to work towards that. These two angles have to sum to 90. The two acute angles of a right triangle sum to 90 degrees. So I got the 47 by subtracting 43 from 90. Then I said, oh, well, these two are supplementary. So I subtracted 47 from 180 and I got 133. And then working with this triangle here, I found 39 degrees by taking 180, subtracting 8, and subtracting 133. And that's 39. Now I have a side opposite that angle, and I'm ready to use the law of sines. So sine of 39 over 22 has to equal sine of 43 here over its opposite side, x. So I cross-multiplied. I divided both sides by sine of 39, and I found out by plugging in my calculator that my pole is approximately 23.8 feet. Now, sometimes we have something with law of sines called the ambiguous case. The ambiguous case arises when we are solving for an angle inside a triangle, and I'll show you why that happens in a minute. But let's just think about when we would have this kind of problem. So I want you to think back to geometry and how you were proving triangles congruent. One was side, 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 angle, side, angle, side, angle, 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 side, and right hypotenuse leg. In all of these cases, if you are given the measurements of the three pieces together, there will be exactly one triangle. That's why you can use them to prove congruent triangles. But there were two ways that you were not able to conclude that you had congruent triangles. One was side, side, angle, and the other was angle, angle, angle. With angle, 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 we produce similar triangles. So there's never going to be one answer for a triangle solving it if you're given three angles or even just two angles. But with side, side, angle, you can get the possibility of no triangles, one triangle, or two triangles. Now let me show you how this happens. So if I have a side and I have an angle here. I don't like how I drew that. Hold on. I'm going to try one more time. Don't like it still. So if I have a side and I have this angle here, and I know that this angle has to be fixed, and I'm told what that length has to be, and I'm also told what that length has to be. It's possible that I can create a second triangle by spinning this side outward. Now let me show you how that happens. Let's draw it in a different color. So I'm going to extend this line, and I can spin this side out. So I'm going to have the option of the orange triangle or the pink triangle and maintain those fixed measurements so I can get two solutions. Sometimes I might get one, sometimes none. Let's see how that happens. So here's my first example, and I'm going to draw myself just a generic triangle, and I'm going to label it ABC. So A is 31 degrees, side A is 10, side B is 16, and you can see we have a situation with two sides and an angle not between the two sides. So I can have 0, 1, or 2 solutions. And I can use the law of sines because I have a side and I have the angle opposite it. So we're going to start there. And sine of 31 over 10 has to be equal to the sine of B, I'd like to know angle B, over 16. So now we'll multiply both sides by 16. And we're going to use our calculator. So let's see, 16 sine of 31 divided by 10. Remember, it's very important your calculator is in degree mode, otherwise you'll get all incorrect answers. So now I know sine of B is equal to 0.824, roughly. Now, I'm going to solve for the angle by doing inverse sine. Second sine, second answer, so that I get that extended decimal and get as accurate an answer as possible. So now at this point, I know that angle B is 55.5 degrees. I'm going to change colors here. 55.5. Now here's the problem. Think back to when you were solving trig equations. Sine is positive in the first and also in the second quadrants. So this 55.5. I will have solution in the second quadrant that satisfies my equation with that same reference angle. So to find that angle that satisfies my problem in the second quadrant, I would subtract 55.5 from 180. And that is 124.5. Now, let's draw ourselves a separate triangle. And instead of 55.5, I'm going to write 124.5. Okay, so now I have two angles in each of these triangles. I should be able to find angle C by subtracting these two angles from 180. Let's give that a try. 180 minus 31 minus 55.5. That's 93.5. And in my second triangle, 180 minus 31 minus 124.5 is 24.5. So it certainly appears that I may have two triangles here. Let's continue with this. I'd like to find each of these side C's. So I'm going to start with my top triangle. And we're going to go back to sine of 31 over 10. That's got to equal sine of 93.5 over C. So we'll cross multiply. And divide both sides by sine of 31. And plug into our calculator. So 10 sine of 93.5 divided by sine of 31. That is 19.4 approximately. Now we have to continue and find side C in our second triangle. I'm going to change some colors again, maybe green this time. Let's make this a little smaller. Okay, and maybe this smaller too. Okay. So going back to sine of 31 over 10 has to equal sine of 24.5 over side C. Sine of 31, angle, opposite the side, 10, equals sine of 24 over its opposite side, C. So cross multiply again. C sine of 31 equals 10 sine of 24.5. Divide both sides by sine of 31. And then use our calculator. So 10 sine of 24.5 divided by sine of 31. So that is about 8.1, rounded to the nearest tenth. Okay, so now let's examine both these triangles. Let's look at the first one. My largest side is 19.4. 93.5 is my largest angle. So far, so good. My smallest side is 10. My smallest angle is 31 degrees. That looks good. Let's look at the next triangle. My largest side is 16. 124.5 is my largest angle. Perfect. My smallest side is 8.1. 24.5 is my smallest angle. So I have two solutions in this case. Now here's another one. Let's see what happens with this. Let's draw our generic triangle. I'm going to label it A, B, C. A is 23, B is 11, and alpha is 122 degrees. So let's solve this using law of sines. I know that I can because I have an angle in the side opposite it. So we're first going to solve for angle B. So sine of 122 over 23 has to equal sine of B over 11. So solving for sine of B, I multiplied both sides by 11. And then plug in my calculator. And I find that sine of B is approximately 0.406. Now we find the angle by doing second sine, inverse sine of what I just got, that extended decimal. And I find that B is 23.9. Now, remember, sine is positive in the first and in the second quadrant. So I'd have an answer in the first and the second quadrant. One's 23.9. The other one is in the second quadrant, with 23.9 is my reference angle. So my other option is 180 minus that 23.9. And that is 156.1. Now, taking a look. So let me change my colors here. B would be 23.9. And then I have my second option. Would be 156.1. Hopefully you are noticing a problem. That problem is that the interior angles of a triangle have to sum to 180. And if I add these two together, it's more than 180. So this will not be a solution to my problem. Turning to my original triangle that I drew, I can find an angle C. So we'll do that by subtracting each of those angles from 180. So 180 minus 122 minus 23.9 is 34.1. Okay, so far so good. Now we have to find side C. So sine of 122 over 23 has to be equal to sine of 34.1 over C. So now we will cross multiply. C sine of 122 equals 23 sine of 34.1, and then divide both sides by sine of 122. Okay, plugging in our calculator, 23 sine of 34.1 divided by sine of 122. So that is approximately 15.2. Let's write that in. And now we have to examine our triangle, make sure it makes sense. Okay, my largest side is 23. 122 is my largest angle. My smallest side is 11. 23.9 is my smallest angle. So This is the solution to my equation, or to my problem, and there's exactly one. In the previous case, I had two. Now let's look at this example. Draw myself the generic triangle. I'll name it ABC. Alpha is 45 degrees. A is 4. B is 17. So again, you can see that it's side-side angle, and I may have 0 triangles, 1 triangle, or 2 triangles. So I can use law of sines because I have an angle and the side opposite it. So sine of 45 over 4 has to equal sine of B over 17. So I'll multiply both sides by 17. And plug into my calculator again. So 17 sine of 45 divided by 4 gives me sine of B equals 3.005. Now, hopefully you see a problem at this point, but if not, I will just continue. So I'd like to know what angle B is. So I would do inverse sine of that answer. So second sine, second answer. And there is the error. This value, sine, can never be over 1. So I get an error out. Since sine is never over 1, I have no solution. Okay, so that's my lesson for today. What you should have learned is that you can use law of sines to solve a non-right triangle when you have a side and an angle opposite it. If you are solving for an angle using law of sines, you have to recognize you may have something called the ambiguous case with side-side angle, and that may have 0, 1, or 2 solutions. Have a great day.